Hello everyone, welcome back and welcome to our first talk of today's kernel miniconf. André Almeida is a Linux kernel hacker at Collabora, where he's investigating how to make game runs faster and better in a free and open stack. And today he'll be talking to us about the current the futex2 syscall and the different approaches that he has been taking so far to overcome the limitations of the current futex syscall. Please welcome André.
Thank you very much. Good morning, Australia. I'm André Almeida. I'm a kernel developer at Collabora, and I'm based in Brazil. That is a place very far away from Australia, but it's a pleasure to be back here. And today I want to talk about this project that I have been working for quite some time now, that is the futex2. But before, of course, I will explain what is futex, why do we need a new futex, what I have done so far, and what is left. So futex is a syscall on Linux. Is used for creating sync primitives like mutexes. So for instance, pthread mutex uses futex behind to be implemented. And it's something that we expose to userspace, so you can create these fast primitives. And given that is used by pthreads, you can imagine that is something that is called very often. If you are using any multi-thread application right now, for sure you're running a tons of futexes. You can trace your browser to see the magic happening. And the kernel interface is very, very simple. It's basically a way to sleep and wake threads, and all the logic needs to be done in user space. And here is like kind of a visual explanation of how the syscall works. So imagine that this thread over here is like waiting. It got the lock, it got the mutex lock. So it's here in user space doing a lot of work. So here we have two threads, and this is the times flows on that direction here. And this thread is happy in user space with the lock taken, doing a lot of work. And then in the meanwhile, this thread here tries to get the lock, but the lock is taken, so it needs to sleep. So what pthread does here, it will issue a futex wait call. So you wait on user space address. This is kind of the ID of the mutexes. So you just wait on this address here until something wake you up, and then you go to the kernel, you do some initial work, and then the kernel call is scheduled. So the processor can do something useful while you are waiting to get this lock free. And in the meanwhile, we can let's say here that this user space thread finished the work, and after finishing the work, you want to give the lock to someone else, and then the user space do a futex call using the wake operation. So we get back to the kernel, we look up if is there anyone really waiting at this address, and if we find someone, we should wake up call, and then this thread get back to user space and can finally do the work. So this is a very basic overview of what is futex. And I said a lot about mutex, but this can be used for barriers, semaphore, for a lot of sync primitives. Okay. And but why do we need a new futex API? So along the years, developers have seen some limitations of how the futex syscall. I will go on all those limitations in some minutes. But basically, the problem that we had been facing is that we wanted to add new features to the futex syscall, but the futex syscall is kind of multiplexed and strange interface. I mean, look at this. You have all those arguments, and the arguments it needs to be very generic, so the arguments have strange names, like this is just vol. This is a timeout, but sometimes can be vol2, and we have vol3 here. So this was made to use a lot of different operations. You can check the main page for all the crazy things that it can be done there. And every time people wanted to add new operations, the maintainers didn't really want to get this in the kernel, because it's kind of hard to maintain that. Yes, it's very tricky to maintain that code. So and then I wanted to add a new operation to the syscall, that is the ability to wait on multiple futexes at the same time, because on the old interface we could just want on a single one. And then they told me, hey, if you want to do that, you need to develop this interface for that. And here we are here, and now we have this project that we call futex2, that is to try to discover how this new interface should look like, and to get all those new features that we want on this new interface. So the first of all, wait on multiple futexes, as I said before. So you basically wait on multiple futexes, and if some futex triggers awake, you just wake up. This operation can be found on other operation systems like Windows. So this is very similar to wait for multiple objects from Windows API. And all of these work has been based on to be used on Steam Proton. So Steam Proton is a compatibility layer that allows you to run Windows games on Linux. And Linux didn't have a proper way to do that, to wait for multiple things at the same time. And I mean, we have like eventFT that can be used for that, but on a very large number of waiters, it doesn't scale very well. And we find out that futex suits better for that. So we, at the Proton, we call this the syscall to wait on multiple futexes to map to this Windows function. And what we saw is that not always you can like increase the frame rate of your game, but almost always you can decrease the CPU utilization or the kernel load that you need to use to wait for those objects. And usually we can decrease the power usage, and if it's like a portable device, you can probably decrease the battery usage and use better the resource of your machine. And this function was merged on the kernel that was released on this weekend, 5.16, and we basically merged a new syscall for that. So all those new operations, they will come via new syscalls. And futex Retriever was just the first of it, so you can happily use it right now. And another interesting use case that people have been wanting to use on futex is variable sized, because the current interface can only use 32-bit values. So you need to use a pointer to a 32-bit integer. But a lot of there are some very interesting use cases that wants to use variable size futexes. People from the Boost library, from the C++ library Boost, they wanted to support variable size futexes so they can create user space atomic operations on top of that. And also, if you have 64 bits futexes, you can like wait on a pointer value. So this will come with the new syscalls, and you'll be able to wait to operate on those 4 different sizes. And also, a big problem of futex right now for really big cloud enterprise machines is the lack of numa awareness. So on futex, when you get into when you want to wait on some address, you need to get on a global hash table, and you'll be assigned to a bucket. So for instance, here we have a bunch of threads waiting for different addresses, and each one will get in a different, you can have threads in different buckets. But the problem is that, well, if you have a non-numa machine, you have no problem. You have just your global hash table there, everything's fine. But we have a numa machine. This global hash table will be assigned to a single node. And basically that means that every other node will have a penalty to access this hash table. So that means that every futex operation that happens outside of the CPU will take a little longer. And yeah, this can have a very strong performance impact on some really big machines. So this is like a big pain point of futex, and this is something that we would like to solve on this new interface. So basically what is left now is to figure out the numa syntax, so we can I think this is the only piece remaining to get the new syscalls sent to the mailing list, is to figure out how should be this numa syntax. So what we have right now is that you send to the operation a flag called futex numa flag, and then instead of using just a plain user space address, you will point to a struct where you have here on the first place the integer, like the futex address, and then a hint that it can be used to specify which node you will want to operate. So the value is just the expected value of the futex, and the hint can be like 0 to max numa node so you can specify which numa node you can operate on, or you can use just -1 to say that you want to operate on the current node. So, but we're not sure yet if this makes sense for the numa applications, the numa vendors. So this is like a research step that I am doing right now and talk to people that need this use case to figure out if this is really a match for what they are looking for. But yeah, I think that's it. This is the state of futex. So now I can have questions.
Please put your questions, if you have any, in the Venulus questions tab.
Okay, so we have our first question. That is, one of the cool things that you can do with Windows wait for multiple objects is wait for a mutex at the same time as an IO result, for example. Is there any plan to get futex notification through epool? No, there's no such plan right now, because futexes and file descriptors did work well in the past. Well, it's kind of tricky to explain, but well, maybe I can revisit this topic. But I'm not sure. It's like, would you be able to wait on the futex using the file descriptor, or it's like waiting on when to get the end of the IO operation? I'm not sure how would be this the syntax. So will futex2 support real-time priority awareness? This is something that we had discussed as well, because basically the biggest pain point of futex and real time is that on that hash table you can have a lot of conflicts, and you can be sure from the user space side how many conflicts we will have, and each conflict increase your time to complete the operation. A few things have been proposed in the past, like each process would have its own hash table, so in this way you can like reduce a lot your hash collision. But from my plumber session, this wasn't a issue, or I mean, this hasn't been discussed again. But yeah, it's a very nice question about how we can get this real-time awareness. But yeah, we don't have any plans right now, but of course this should be discussed again. And another question, other than Proton, do you have other expected use cases for written on multiple futexes? Well, I know that some game engines want to use these as well, and the Boost library people also told me that they have some kind of mass locking API that could benefit from this as well. But yeah, basically this seems a very common load pattern for games to do a bunch of work and wait for everything to get complete to go for the next frame, something like that. So basically it's a round game. Are there any performance issues with the new syscall? No, not really. The new syscall basically is kind of a front end for the current futex code. So yeah, the performance is very similar. The performance of this operation is very similar of the other futex operations. Can we avoid spurious wake-ups with futex2? Well, I don't think so as well, because to avoid that, you would need to really have the kernel involved in the uncontained case. You know, if the lock is free, we will need to talk to the kernel anyway. But yeah, we can't avoid that with futex2. It's not something that we solved with our design. And yeah, unfortunately, you will need to wake up the thread, and the thread will need to fight for the mutex, and it can lose. It can get back to the kernel, and this is really key to design of how futex work. So yeah, unfortunately we can't avoid that. But as far as I know, it's spurious wake-ups are not like a very big concern on the performance side. Syscall, yes. If Allison is asking if futex will support PI priority inheritance using the recent added kernel flags. So so far no. So far no one proposed a use case that would mix it these numa awareness and these variable sized futexes with PI. So I don't think so. Yeah, well, it seems that people have a lot of good ideas about what we can do with futex, and basically this talk is, of course, is like a status of how this project is going on, but it's also for really to listen to those ideas that people want to have on the API. So yeah, thank you very much. I will take all of these into account. And yeah, let's see. Maybe next year I will come back with all those schools operation at futex. Andrew, I don't think we have more questions.
I don't see any more questions, so I think that might be it. Thank you very much, Andre. Thank you for a great talk.
Thank you.
We will now be going to a break. The next talk will be by Paul McKenney about torturing RCU, and that will be at 11:30, which is in 17 minutes. See you then.